This lecture is going to be a bit more of just talking and not much coding, as these are important concepts to understand. With that, there are three traits that we need to cover. We have FnMut, and FnOnce. Fn is the family of closures and functions that you can call multiple times without restrictions, and it borrows values from the environment immutably, and this is the highest category, and it includes all little f, includes all Fn functions. FnMut is the family of closures that can be called multiple times if the closure itself is declared mute and mutably borrows values. FnOnce is the family of closures that can be called once if the caller owns the closure, and then the once part of the name is because the closure cannot take ownership of the same variables more than once. So every big F, Fn, meets the requirements for FnMut, and every FnMut meets the requirements for FnOnce. And this means that Fn is a subtrait of FnMut, and FnMut is a subtrait of FnOnce. Therefore, we can conclude that Fn is the most exclusive and most powerful trait of the three. So let's take a look at three separate closures and try to establish which trait each example falls under. So the first example is going to be a closure that takes no parameters and then drops a value. The second one is going to take an argument and then check to see if a vector contains the argument. And the last one is going to also take an arg, and then it's going to push into the vector that arg. So take a second and try to establish which trait goes with which example. Alright, so the first example is going to be FnOnce because we can only drop the value once. The second example is going to implement Fn because all we're doing is checking to see if the vector contains the parameter that was passed in. There is nothing required in this that needs to be mutable. And then lastly, this is FnMut because the vector would need to be mutable in order for us to push the argument into the vector. And that's really all there is to it for the Fn traits. So now let's talk about copy and clone with closures. The rules for copying and cloning work like the regular copy and clone, and Rust will automatically figure out which closures can implement copy and clone and which closures cannot. So let's take a look at two simple examples. So for this one, we're going to create a value y, assign it 5, and then we're going to create a closure here that's going to take an argument and then add it to our y value. And now we're going to take a copy of the add y closure we created. So this is closure being copied. And now we can check to make sure that our copy actually worked correctly. So we can say add y, and then in here we can also call copy, and we'll give it the value 10. So if this copy works correctly, we would expect 20 to be printed out, because here where we designated that the closure is being copied, we are going to add 5 to 10, and then on the outer call we're going to add 5 to the now value being passed in of 15. So if we run this, we got the expected output there of 20. So now let's create an example where neither copy nor clone works. So we'll actually take this and we'll modify it a bit just to keep our example very similar, and we'll put mut y, and then we'll do a mutable add y, and then we'll also even make copy mutable, and then in here we are going to modify the logic being done. So we're going to say y is going to plus equal x, and then we want to return y. And we see that this is already not going to work, but if we run it anyway, we see that the value was borrowed here after a move. And remember that this does not work because mutable values do not implement copy or clone. So that is why this does not work, even though our changes were very minute. But all in all, closures are not overly complicated. And I know that the past few lectures were more theoretical than it was hands-on, but we will actually see where closures shine in the next topic of iterators.